Tell me about what you're doing here.
Alrighty, so basically we're cutting we've already cut the throat diameter, and we've already cut our combustion chamber in these heads, which is basically our relief above the valve. So now we're going, yeah, that's our relief above the valve.
Yep.
That's our throat diameter. So we've sized that properly because really that was undersized stock for what it optimally would be on a ported head.
And why do we want it bigger?
More power. Actually, it's a diesel, but you know, more power.
Well, it's going to go in a pulling tractor. What is that tractor? A 14.6 or?
I mean, it's a DT 414 to start off with, stroke to a
The engine,
466. So I mean, would be the same in a truck or anything else. Right? So basically, this is going to open up flow a lot. Before it had just like a solid 45-degree angle. Like the valve job was like this, and then it had a straight wall like this, basically on the other side of the valve. So now we're going to really have. We're going to give the air some place to escape, and it should help the low lift flow. By
opening up that chamber, you're...
Yes, exactly. Yeah. And we're deshrouding the valve. It'll help low lift flow all the time. And high lift flow. It's just good all the way around. And then our throat diameter is just sized to the application now. So at least, you know, it's sized to the valve.
Yep.
So I mean now, if you look at the valve, you look how open it is around the valve.
Yeah.
You know, if we go to open the valve of skosh, it's gonna have, the air is going to have quite a lot more of a pleasant path into the chamber. Are you
gonna back cut that valve or anything?
They come with a back cut radius.
Yeah. The intakes really don't.
The intakes really don't, but I mean, usually a 30 degrees about this is the same angle we run our back cuts on all our V8 valves higher.
So that's a 30 degree right off.
It's a 30 degree
shelf.
Yep.
Okay.
And see how thick those are too.
Yeah.
In a pulling tractor or something like that, you really want that margin because these valves are going to get hot,
hammered.
Hot.
So you're gonna. This is the exhaust side is cut. The seats are cut.
Exhaust side is cut. You can see the intake side just is sharp edge.
Cut.
So
it does make quite a lot softer edge, doesn't it? It doesn't show as good on the camera.
And we're gonna have a ton of porting down in here. A ton of porting.
Yeah, you're gonna cut all that.
A ton of porting. I mean, even that, it's so ugly down in there.
Blend that.
So no, there's still work to do, but it's all part of the process. So far, I've got probably in this valve job, I'm right around 3 hours so far, really. So I mean, there's time involved in this thing.
You're gonna have a lot of hours of hand porting.
A lot of hours of hand porting. I mean, we're not gonna go crazy on the heads, but with our amount of hand porting we're gonna have, I would assume we're gonna have at least 15 hours of hand porting.
And you ported the exhaust manifold.
Exhaust manifold again. It was a smaller job. I mean, we want to keep some meat in that stuff so it stays together, but just removed a lot of the large casting flash. And there was certain stuff like where the bolts are for the turbocharger. It had big bumps into the ports, and it was just a restrictive exhaust manifold. So we cut that back, and you have
to run the stock manifold because of rules.
Exactly, and the stock intake too. There's not much you can do in the stock intake.
No, there's not a lot of meat in it,
but there was quite a mean edge there that I took down and ported out of it. So the only other thing I was thinking is we could raise the port height a little bit, but we're going to get really thin on this gasket. So I think probably our best bet is going to be just to clean this stuff up. Yeah. And you know, we're going to get the 90% that's easy to get, and if ever we want to revisit it. Yeah. And he
was actually talking about getting another head to do experimentation on.
Yeah, well, and intakes and stuff like that. I mean, we could cut and section an intake and make it look like nothing ever happened to it, you know what I mean? Yeah. So there's definitely some stuff we can do. I mean, we're going for the 90% right now. So this is going to be the big stuff we'll be got. So.
Then we'll have to come back and show you when you start doing the intake side. That's the exhaust side.
That's exhaust.
But they look just the same. The ports look very similar.
Very similar.
From one side to the other.
One weird part about these motors is it's a common intake plenum.
Yeah.
Which bolts on the head, so your runners all end there. Yeah. So we actually need to, that's another thing we need to do once we get the valves in it, or mocked in it. We need to actually measure our port length and make sure the port length is the right thing for the RPM we're going to run. If not, we can make a port extension that comes into here, or we can even put...
Can't really extend into here very much.
Oh, we're extend a bit. And worst case, if hopefully it's too long and we're going for shorter runner because we're running higher RPM, in that case, we can put a very large radius on the intake port to make it think that it's making it to the manifold before it actually is. So that's all stuff it's all in the math, and we'll be back soon.
Yep.
Because that corner's 90 degrees and super high. There's
trying to lower it.
Absolutely. I mean, I'm not gonna right now. I'm just mainly trying to get rid of that ridge right this second. But definitely, we have to actually put a radius in that. I mean, it's like a 90-degree corner right now. It's terrible.
Started out like that with that ridge.
Yeah, we're pulling.
Now we're doing that.
We're starting to pull the ridge out first, and then we're gonna work it on the corner.
You've actually, you look in the two. You're working on the corner some as you go.
Some. I mean, tell how bad it was stock. I mean, it's gonna be a lot better than it was.
Yeah, there's a lot to be had right there. Some material.
That's for sure.
It's gonna be lighter. You do have quite a lot of work doing there, don't you? What are you trying to do right now?
Just getting that thing all blended out still.
That's it, that's all.
Still, yeah. I mean, then I gotta do the intake side. I still haven't touched the intake side yet.
I thought you did the intake side, but
I
had
did
to
the
swap
intake
over.
side there.
Yeah.
But I didn't do here.
Yeah.
So that's my next order of business, and then I'll probably change up tooling, get a flame shaped bit, and go from there.
What's the difference between this one and doing like a gas job?
This, it's got that swirl. If you show down, pan down. See, it's got a swirl hump like an 80s Chevy. Like
oh yeah, put the light in there so you can see it.
Well,
okay.
I'm trying to.
Yeah. Huh.
So we used to work around the swirl ramp.
Yeah, it is. You can see it's good like from here. Eh? It's weird, eh? So what does the swirl ramp make you do different?
You have to keep it. You have to maintain it. You have to figure out how to.
You don't want to disturb that.
No, you really. I mean, you can disturb it a little bit, but I mean within reason.
Interesting.
Like that, you can kind of see what the part is.
Yeah.
But you look in here. I mean, it's all belled out. It has like way more port there.
Yeah.
And it would stock. And
it does dip in there pretty good, doesn't it?
So there's a lot of different shit that you have to do on this and everything else, but it's just a lot of hours. We'll see how this one performs, and we'll go from there, I guess.
Yeah, that's it. Learn as you go.
So this is clean work. One got me in.
Several hours later. Several hours to go.
Several.
How many hours do you think to go?
See, when I really get into measuring the ports and stuff, but I mean, just in blending, finishing the bowl blend up, you know, on the intake side, like finishing profiling that
up here.
That wall and
that's
that
exhaust
wing,
side.
and that wing here.
You gonna profile that wing?
I have to profile that wing for
Oh,
sure.
yeah?
Some, I mean, I'm gonna give it every chance to flow it can have.
Okay. Well, I didn't know if that was
I mean,
going
I
to
have to
disturb.
maintain the wing, but I
Yeah, I didn't know if that was going to disturb your swirl. If you profiled it.
Well, no, I have to keep the wing, but I mean, I can lose a little bit. If you lose too much, it just won't run at all.
Yeah.
I mean, if you lose a little bit and gain a bunch of flow, I mean, you know, there's a happy medium. Everybody in the diesel porting industry basically says there's no win necessarily. There's no perfect end of the rainbow. You know, because in losing swirl, you lose a little bit of mixture there, but in gaining flow, you make more power. So,
Yeah,
you know,
you've gained a lot.
In the name of flow so far.
Now, I mean, like you picked up a lot of area.
Yeah.
Which should make flow.
Yeah. Well, I haven't gained that much area necessarily. Just everything like this. I mean, like
well, you go back.
These I've already moved. I mean,
you go back and look at your your throat when you cut it.
But I mean, like this, I've already moved here. Say where this one looks more done than that one, so we'll use that one as a reference. You know, like this around here was very 90 degree before. It still needs more work. It's not perfect, I mean, if you put the light down below it, you can look through the port and get a general idea. You know, I've already pulled that down a bit. Now, I don't have my long porting bit on. That was just a preliminary to get a basic shape idea. So now I'm going to go in there with my longer porting burr, which I have like a 6 or 8 inch long porting burr. So now I'm going to be able to get over top of that and also catch it from the other side and pull that down. Usually in our gas engine stuff, we're right around a 1/2 inch radius right at that tip, and then a gradual sweep after that. So like something like a 1/2 inch radius. So
we do have a few differences on this though, being direct injection and stuff. We don't have fuel and suspension.
We don't have fuel and suspension, but the air still has to make the turn.
Yeah.
So the fuel, you're right. There's no fuel.
But the air making the turn affects us a lot when fuel's in suspension for combustion and everything.
But it also, okay.
You know,
now,
I mean,
conversely,
does it matter as much?
Why would it have a swirl ramp if it didn't? That's the answer. It has a swirl ramp for a reason. There has to be mixture, because this point in the cylinder is always technically going to be dry, because the air's got to go here. Now, the idea with that is they're making it go the long way around.
But that injector comes out there on a spray.
I understand the injector comes out there on a spray, but if you don't have fuel to pick up, if you don't have air to pick up the fuel with the injector spraying, you're just puking fuel on top of the piston and making heat for nothing. That's the whole theory with the ramp is to have very even air distribution throughout the entire cylinder so it can combust. So, I mean, that's kind of the technology behind it.
You're really a nerd.
No, I just kind of, you have to do research and understand things so your customers don't think you're an idiot.
I'm down low here. You can give me the folded arm cool dude stance.
Next time on Discovery Channel. I don't know what else. But no, tomorrow we'll come back. I'm probably going to keep going a little bit.
Keep hammering.
Try and profile on that. And then our intake side, actually can flip it down. And
you got to finish your valve job with a stone sill.
Yeah, I'm going to save that for dead last. So I've got my angles in there and everything like that. That's all good. But I'm going to, again, we're going to wash the head again before that. I'm going to
hammer new guides in.
Yeah, new guides. The seats are all ground. I cut my combustion chamber out. It's just, this is fine for now. We're just going to go back and we'll just touch to make sure the valves seal perfectly. We'll lap all the valves. Because on this, especially a diesel thing, God, if you lose a little bit out of a valve, you will kill an engine. Yeah. Just kill the horsepower completely. So.
Yeah, well, you're such high compression ratio.
And like this, we're going to peel back these edges a little bit. Even the stock DT466 truck heads and some ag heads, they all have a radius there. Okay. This is a 414 head, so this doesn't have that. But we will add that. And of course, after
Are you going to do it anywhere in the runner, or is it?
Yeah, we'll do it. I'm going to measure it and see if it's the right size for the RPM we're going to be turning it. We'll size it.
The casting and everything looks fairly smooth. I mean,
yeah.
There's not like obvious casting flash and bullshit you can take out.
No. Yes.
I mean, like typically, where's them 440 heads? Yeah. Right here. Typically, you look at something like this.
No, I mean, that is how this started.
And you can see, yeah, but you didn't have like a lot of these kind of big, edgy.
Well, no, because I cut them out.
You see that big corner right there? That thing's a monster.
Well, we had a lot of that in this engine.
Yeah, where you did your throat cut, yeah. But this, like all this stuff is easy horsepower you can get.
Definitely.
That's, I mean, I don't care what you're working on.
Well, that's it. Even if you're working on something that's going to run in a stock power band with a stock cam, hey, if you come in here with a stock camshaft and you peel that stuff down and give it a nice valve job, the engine 100% of the time is going to make more power. Yeah. I mean, it's impossible that it doesn't. So no, just optimizing what we're working with, because I mean, this isn't a project. We're limited to this head. And honestly, I don't think, on guys year one of pulling, it's the smartest thing to go and do a full crazy race porting and
but we're limited to the intake and we're limited to the exhaust manifold.
We're limited to a stock intake.
So I mean, we're only going to feed that and be able to evacuate so much.
We could do some pro stock crazy, stupid shit and make insane gains with it, but this is the 85 to 90% that's going to be fairly easy and attainable, just like anybody could do at home on their 440 heads or anything like that. We're not reinventing the wheel. We're using stuff. I mean, bring it to your local machine shop, have the seats done, you know, have guides put in something. This is, we're doing a reman with some performance modifications, you know. I mean, a normal reman like this, we would pound new guides in it, same as we did, hit it with a stone, do a 1-angle valve job, that's it.
I think if we would have been rigged to put that thing on the flow bench, I would have loved to have seen it before and after.
I know these guys talking about some of their heads in Super Farm and stuff. They're getting these almost 400 CFM.
What do they start out as?
I think they start out 280 or something like that.
Well, that's a big change.
Oh, hell yeah. But you also look at these things and it doesn't even look like a 466 head. You know? I mean, just the valve job alone, I think. And they go to a 2 1/4 inch intake valve.
Yeah.
I mean, those guys they're doing some stuff that's really insane, you know.
I think your valve job alone though, you're gonna
yeah. Well, we're sticking with stock valve dimensions, so it's a 197, 159 valve. So, you know, that alone, I mean, you know, sure, if we were to go to a 2 1/4 inch intake valve,
I'm pretty sure
we'd be cutting out another 1/4 inch of material. You know, you need to almost everywhere in the port, so it's not realistic for the budget for what we're doing with it. This is the best way to get most of the power.
I wouldn't be surprised to see you picking up 20% over stock, you know.
I would hope at least 20%. Yeah. So if it was only 20%.
But no, but I mean just on your valve job and your bowl blend.
Oh know? Yeah,
like your other work.
A solid 15.
Your other work, I'm thinking is
probably a solid 15.
Well, you moved a lot of material out of there, and it is way smoother now, and it should definitely.
I mean, everything, as long as everything can make the turns better, get in and out more efficiently. That's all.
But I still say if we're stuck with that stock intake and exit, we're kind of limited.
Yeah, 100%. So I mean, we're working with the package that we can. Yeah. Yeah. I mean, like he says, there's no point in going and doing all that crazy stuff when we are stuck with the stock manifold and the stock bolting locations and everything like that. You know, those Super Farm guys and stuff like that, I mean, they sell aftermarket head castings of these with a 1 inch higher port. I mean, you know, you're putting the bottom of the port here. Yeah. You know, you're raising the port up like a pro.
Imagine the inspectors would notice that.
Well, I imagine they would notice it on something like this. But I'm saying it's not realistic for this to do that stuff.
They probably don't sell a stock looking exhaust manifold to go on it.
Probably not.
And but those exhaust manifolds,
I think we were lucky enough to find one without cracks in it.
Yeah.
Because apparently these are very bad. And the exhaust manifold, I mean, speak of a wonderful piece of craftsmanship. It has that 2-piece joint in it. And, well, on one end, it was perfect. You know, the big end, it was perfect. And then the small end where it slipped in, well, they didn't have it slipped in the right amount. Or it was cast wrong.
Probably wasn't
machined wrong.
To slip in far
So
enough.
it went over the studs fine. Yeah. But the port was over 1/4 to 3/8 of an inch. So we had to cheat the exhaust manifold and kind of port an edge into it to at least give it a smooth transition. So, I mean, there's a lot of stuff like that that's not ideal.
Too bad we couldn't build a header for it.
Yeah, exactly. If we were able to build, like, what I would do for this is, like a Schedule 80 stainless manifold. Yeah. Because that's what a lot of the turbo guys do, even LS stuff. A lot of your bot, like Fowler Performance and stuff like that, all your bot manifolds for turbo stuff, high heat stuff, they use cast aluminum or cast stainless elbows, and then we would cut flanges like these here. We cut some for small block Chevy to do stainless headers on. Yeah. So I mean, you would do something like that. So that's a 3/8 inch flange, or 3/8 or half, and we would go ahead and weld stainless elbows onto them and stuff like that. And I mean, we can get this. You know, if we brought a profile of that side of the head, we could have that cut locally and just build right off it. So.
Yeah, we got guys here that cut that stuff for us. It's pretty nice.
Exactly. And
intake too. You got your intake pieces down there.
Yeah, and I mean, really, honestly, it's a big enough engine. This could use a T6 back housing, so it could use a semi-truck frame, normally back housing. So on that, I mean, which is really Hollywood about that, is they even sell nice divided flanges. So you do a divided inlet with two 3-inch pipes or 2.5-inch pipes, and it's all out of billet stainless. Yeah. So I mean, if we were to build a manifold, you get one of those flanges. Flange alone's like $250. Yeah. So we get the flange, we'd cut the thing, get the scheduled tubing, and really do a really Hollywood job of it. But
we're not allowed.
We're not allowed. And I mean, the intake, I think, really honestly, if you could split the intake or weld tubes into the intake, and raise that, you know, we could raise that port up almost, you know, top of the port, we could move it, you know, 3/16 of an inch.
But I mean, we could, well, we can't move it now only because the damn intake manifold.
Yeah, we would have to fake the intake manifold, which we could. I mean, the intake manifold, there's nothing saying...
I mean, you could raise that roof a little bit now just in pulling it out, but it ends.
If you were smart, you could really, you know, do something there. Really, I think the main play on that would be you just, you know, you would
split it.
Keep this part. You'd almost have to split it. But I mean, at that point, you could keep your, you know, you'd be raising up here. You would, I guess the bottom I would try and keep the same spot. So that would...
Because this distance in here is the same height as the runner, the port that's in the head.
I would slit it.
Yeah.
And or just cut this all out to start off with and build it up here and tube these through the manifold. So, you know, we would raise that up to here, plate that all over, and then run that with tubes that are welded out here and longer bolts. I mean, they would, if anybody knew what they were looking at, they would notice, you know.
Yeah, well, these guys are probably used to looking at them and inspect those. I think they'd catch it.
But I think this is kind of a Quebec-only rule because I've read of a lot of other people doing farm stock that are putting aftermarket stuff on it. So.
Oh, I don't know.
So
I didn't see the rule book yet. I'm taking his word for it.
Yeah, we're also just taking his word for it. But
I'd like to see the rule book.
Because I do think...
If you want to cheat, the best way to cheat is to know the rules.
Because this is a shit design.
Yeah.
I mean, it's an open plenum. Yeah. Okay, well, this side's nice. It has a good radius to it. This side's a square end box. I mean, so there's no way
Why the hell would they have that difference?
There's no reason this and this are getting the same air. Either A, this is choked off, or B, this has a big old dead corner in it.
That's strange.
So this is stupid. This is already stupid. You know what I mean? But to boot, you could also have a intake with a, you know, the plenum's small. It could also have an angle upwards if you're able to do a sheet metal intake or something like that, and actually, you know, feed it with a ram a little bit.
I know for a fact we could build something better than that, but
so
anyway,
you know, to boot also, I mean, we don't know that the runners are really the right length. Hell, there's nothing saying we couldn't build an individual runner intake for a while longer. You know, say we need to come out here with the intake manifold and then put, you know, a tubular.
You haven't done the math on that yet, though.
I did a while ago, and I need to measure it. So I have it all written down. But the thing is, this thing's so short right now. We're tuned at the 8th induction wave, which we never do on like my small block intake. I'm tuned on the 2nd or 3rd wave, which is normal. A lot of people do that. Because like the first wave, that's why you saw Chrysler in the 60s with that 413, with the intake that went like...
Oh, the cross ram.
America! Fuck yeah! Put the carburetor over here.
Yeah.
That's tuned on the first induction wave.
Yeah.
So as you tune on more and more induction waves, you can shorten and shorten and shorten your system. So like my tunnel ram, you know, I have like a 5-inch runner on it. So that's plus, you know, in your head. I'm tuned at 10 inches, I think, for my combo, which would be on the 2nd induction wave. Well, this, as short as this is, and the low RPM and what we're doing with it, this is tuned on like the 8th wave. So the problem with that is your induction waves keep getting closer and closer together. So our point we have to hit to be in tune, to have the intake in tune with, you know, have the intake length in tune with combo, is so freaking tight together that, you know, we can miss it so easily. It's not like if we're out tuning on the first wave. The first wave is easy because, you know, your window, you know, if you're 2% off, your 2% is so much larger there than if you're 2% off here and it'll screw up.
Does that induction wave affect us as much when we don't have fuel and suspension?
Yes, it's ram tuning. It 100% doesn't matter. It's scavenging. It's the exhaust pulling the intake into the chamber.
Okay.
So 100%, it just is. It's an airflow thing. It does not matter whether it's gas, diesel. It doesn't matter. It cannot matter.
Okay.
It's a constant.
Okay.
So no, that's one of the things we're working with. We need to do our math there. You know, if we can build an intake for it or something like that, I would love to, because I think there is a lot we can get out of it. At the same time, too, it's a very simple. It's something that can be done at a later date.
Yeah.
If we do our math now, we know what we have now, we can do something at a later date. You know, really intake and exhaust off this head would be killer to be able to do that. So I mean, we'll keep going on this as it is. For now, we're not going crazy. It is what it is. You know, in theory, we can do all these great things, but you know, that's not what we're working with. We're working with something. This is a mild, you know, mild to medium performance upgrade.
We're caught in the confines of our casting.
Exactly.
Is what we are.
Exactly.
Yeah.
So we'll get what we can out of it. I mean, like, we could do all that crazy stuff, big valves and all this stuff, but really, in the confines of the intake and the exhaust manifold, it's not in the cards. It doesn't make sense.
You're not going to gain anything anyway.
Exactly. It's going to be a lot of work and a lot of money for nothing. So this is what we're working with, and we'll keep updating you.
Looks like that's a job.
It is. It cuts very slowly. So basically, like the DT466, the real heads, they're radiused on both sides, except obviously the end port, because the manifold ends there. So we're doing that, which should make the runner think it's a little shorter too, which should help with a little bit of the higher RPM than stock action. And it should really help the airflow get in there better, that's for sure. So that's I'm just grinding right now, just my 45-degree belt.
Yeah, you get this one kind of rounded over here, huh?
Yeah, this one is rounded.
You've rounded that side. Yeah. You see how small the chips are. It is hard stuff.
No, it is. And, like this head especially over some other older cast iron heads.
Yeah, this serious cleaning on your machine there.
No, this head's really hard.
That's good cast.
Good in a way. Not good if you're grinding on it.
I used to haul that iron powder though.
Yeah.
For casting.
Yeah.
And there was all kinds of different mixes, I know of it, and shit like that. It's heavy, oh my god.
For sure.
You put
well, I mean, think the amount of powder that's in this is almost 200
put a
pounds.
single row of skids down through the trailer and you were
Overloaded probably.
well, we were legal, but you need to be a really light tractor.
Yeah.
You know, we could haul 50,000 legal, and it would be
All of it.
50,000 one row. You know?
Yeah.
You see the difference in that surface, don't you? It's been warm a few times in its life, I guess. There is no plane now, but it's very good. Well, I could be too. Oh yeah. Fast speed, eh? Wow. Either speed or slow wheeler at fast speed. Jumping like that. Well, that stuff rolls through the production line. They don't want to screw around forever. Coming on. That's all. Off that airgun. Definitely coming. Just slow feed. So tell me about your finished product.
Alrighty, well, where we've got to on this, we ended up boring, as you guys saw, we bored out the counterboard, everything.
Yeah, we had.
Got the throats out to the right size. We put the radius above the valve job, did the multi-angle valve job. Quite a bit of porting on that wing that was in there.
Yeah, well,
The swirl port, which
I think we showed that.
We did look at a little bit. Other than that, on the exhaust side, we did a fairly just basic gasket match because it was very good, honestly, the stock exhaust port. The only thing is the short sides were both terrible on both sides. So we really worked the short side and the bowl. Most of the work we did on these heads was short side and bowl.
Yeah, I think we showed quite a bit of that.
And then I don't know if we showed the intake side, but how we did the intake side. We did the intake side like the true DT466 heads, like the truck heads and everything. They stock come with a radius at the air inlet. Obviously not on the edge because you know you can't. But so we radiused all the air inlets as the 466 is done.
Doesn't really show on the camera as much as it was done. But...
Yeah. Oh, but there's about a ½ inch radius there, probably a 3-inch radius. So we did that. Little bit of porting on either manifold. Definitely more so on the exhaust one than the intake one.
Don't drop a ball.
It's not that heavy. The intake manifold was pretty small amount of porting. We cleaned it up mainly. There used to be a very big ridge right there.
Yeah.
So cleaned that out of there with the carbide burr, hit it with the sand roller, and then we just cleaned the intake up so you could paint it or leave it for all aluminum. And then on the exhaust manifold, I believe we did show a bit on the exhaust.
Yeah, I don't think you showed the, well, you haven't, we've got it ceramic coated
Now it's ceramic coated. So we had, I don't know if we showed, but since the manifold had such a misalignment in the two pieces because it seamed there, we had to cheat the ports over. Because stock, it had a huge port overlap, and there's no way to separate that manifold from itself.
It doesn't really show that much, other than your thinner here on the
exactly.
casting.
That's exactly it. So
you can see the other side, how thick it is on each side of the casting.
Exactly.
Here, but yeah, this joint right here.
Yeah. Well, that joint, and I honestly think whoever drilled those holes just they missed their shot. So, anyways, it's all planed. Quite a bit of porting through here. Like quite a lot.
Yeah,
because on the corners where all the bolt holes were, it had like quite the lump in there to add material. So we pulled quite a bit of material out of there.
This surface was planed.
That surface was planed. That surface was planed. So it's all fresh. And then we sent it over to our buddy Percy, DPR Coatings, and he did that whole finish in gunmetal, and it really wasn't expensive. I think we're only into $200. So I mean,
yeah.
$200 to do a really nice sandblasting and ceramic coating. I think it's money well spent.
No, you can't go wrong.
So no, it's you know, it actually is a pretty nice setup when we're all said and done here. So, that's how she be. That's how she be right there.
Yeah.
So
maybe. Yep.
So that'll be that. So that's cool. Full setup.
I'm pretty sure the turbo mounts up, not down, but
I'm pretty darn sure the turbo mounts up, not down. As I recall in the last one that I actually built, the turbo definitely mounted up.
yeah.
So that's all set up. That's brand new valves, brand new guides, brand new springs. They're double springs. So
One thing on these you have to be careful of is to make sure this valve doesn't protrude the deck surface.
Yeah, there's a.
Because you will have an interference problem with these engines.
Yeah, they're very close.
Yeah. We ran into this on the customer engine.
Where it wasn't really because of our valves, it was more because of his sleeve kit.
Yeah, the sleeve kit,
The sleeve kit and the pistons, the pin height wasn't the same on all the pistons, so we had some pistons protruding the deck and some way down in the hole.
we didn't do anything with the short block. We just did the head for them guys, and then they called up and had a bent valve. We went and looked at it, kind of curious what it was, and it actually was.
It was the
a
piston.
cheap sleeve kit.
Yep, the piston protruded the deck, and so we had to cheat.
We put a dial indicator on it. We started measuring. What the hell was there? Like 35 thousandths difference from one piston to another.
Sleeves, yeah.
So
didn't make any sense. So long story short, and I didn't, so we had to just cheat it and cut a
valve relief for the piston.
Well, or cut a seat a little deeper. That time we cut a valve relief for the piston. But
Yeah, we didn't have our equipment there.
Yeah, exactly.
we just put a new valve in it over there.
So now, like this, you know, our quality control on this is really good.
Yeah.
You know exactly.
This is going to get the shit honed out of it.
Yeah, no, this is going to get
mean,
beat. It wasn't super crooked. It was a little funky.
I got a little video of it. You can kind of see.
On the exhaust side of it, I believe it was the exhaust side. It sort of touched everywhere, and both corners sort of touched everywhere. But
both corners touching though is
But
common.
in through here, we had like we had a solid 5/6 valve bow in it, but which is normal. I mean, all your combustion pressures hit the center of the head. I mean, you put your center head bolts in first. It pulls.
The other thing too, though, is
like,
you know, when things are run across the line, and you know, I've seen the way they jig those things on a line going through the planer and some of the old stuff.
Yeah, it's not.
I mean, it's not really jigged. It just sits on a belt and goes through the planer.
Yeah,
so
no, exactly.
it's
So no, this should be a good, safe, good. We didn't go crazy on our porting, like we did a nice job, but we're this side of anything nuts.
well, considering he has to install intake and intake and exhaust.
Yeah, exactly. We're fairly limited, and I mean, there's only a certain amount of air you're gonna, you know, move
push through those manifolds.
Well, that's it, exactly.
Yeah.
That exhaust manifold's probably the largest restriction. I mean, by the time you get to here, you're filling 3 cylinders through an 1.5-inch pipe. You know. Yeah.
Yeah, if we could build an intake and a header for it.
Even the intake, you can get away with a lot on this intake, I feel like. So, but that is a horsepower rob. So that's basically the long story short. So we got double valve springs, new, all the hardware is brand new. And I guess he's gonna get it on the tractor, and we'll see.
I'm curious to see it run.
See how she runs. I mean, it's gonna be definitely something new for us. That's for sure.
Yeah, definitely. Do you want to port another one right away?
No.
Yeah.
No, we had like 20 hours in that thing, and like really, if you look at it, it's like, oh, that's not a big port job.
Yeah.
You know, like we did a moderate, good upgrade performance job. Like that on a set of like V8 heads, I would have had 8 hours in, 9 hours.
Iron heads?
Iron heads. And this thing, the cast iron in this, I can tell you, is not the same thing.
No, the chips were small. I think
as some of the old
hard as a
cast
rock.
iron stuff, very hard.
Mm.
So I mean, good quality stuff.
Even planed hard.
Yeah.
Yeah.
So I mean, good quality stuff. They'll never have an issue with it. But you know, fact of the matter is, it's hard to work with.
We're good. That was a wrap.
Cool.
All right.
Perfect.